In this second example of a collision, we're going to take these two spheres and we're going to do an inelastic or a sticky collision. The first example was a good example of a elastic or bouncing collision. Many times this will be the way two cars hit and stick to each other. The same principles are governing this. The initial momentum combination has to equal the final. That means the mass in the first one, which is now 1 kilogram, and the mass of the second, which is now 3 kilograms, when you multiply them by their velocities, which are given on the top, should come up, and you can see the totals here are given. You have a half a momentum unit and 3 momentum units. Now, this is in the negative direction, so when we add these together, we have a half of a momentum and a -3. That gives us -2.5 momentum units to the left. Okay, let's collide these, and then let's go ahead and see what that does for the after collision. We had -2.5 momentum units. Now, after the collision, here's the momentums. The 1 kilogram mass is moving at 0.62 meters per second. 3 kilogram mass is moving at also 0.62 meters per second. It's a little off on there, but that's roughly, they have to be the same because they're stuck. When you add these up, you get 0.62 and 1.88, which is, again, not a half, but 2.5. That was my bad. A -2.5 momentums to the left. So, as we did see before, let's just take a look. We have 2.5 kilograms per meter second, or 2.5 momentums to the right before the collision. Sorry, to the left before the collision. The total is 2.5 momentums, and after the collision, there's still 2.5 momentums. And so, either if they stick or if they bounce, that momentum still must be conserved. And that's how you do these problems: is the MV problems, and then set them equal to MV. You'll have some where I won't give you one of this values, and you'll have to calculate for one, like a velocity or mass or something. All right, that's how you do them. Thanks.